Hello. Today, we're going to be talking about random variables, and specifically the binomial distribution. Now, I think it's going to help to understand this by giving you an example. So, let's say Rao, a noted cube enjoyer, rolls 5 six-sided dice. What's the probability that he gets exactly 2 sixes? This is an interesting problem. I mean, how do we know it's even a binomial distribution in the first place? Well, I'll tell you, it's because of bins. And not rubbish, no. Bins as in binary, that is, Rao either gets a 6 or he doesn't. Independent, that is, the result of one roll does not affect the result of any other roll. Number of trials, that is, Rao is rolling a fixed number of 5 dice, and same probability. That is, each die has a probability of 1 6 as coming up as a 6. But how do we calculate this? Well, I'll tell you. Let's just look at the case of getting 2 successes and then 3 failures, where a success in this case is rolling a 6, and a failure is not rolling a 6. Well, from the 2 successes, we have a probability of 1 6 squared, and from the 3 failures, we have a probability of 1 minus 1 6, or 5 6, cubed. But what about success, failure, failure? This would also have 2 successes out of 5 rolls, but how do we count that option as well? We need to count all the options, so to do this, we use the choose function. That's basically just saying if we have 5 objects, how can we choose 2 of them? Like if we had 5 crewmates, how many ways can we choose 2 to be the imposter? Remember, just think of modus. And so in this case, we have 5 rolls, and we need to choose 2 of them to be successes. So we just multiply 5 choose 2 by what we have here. This leads us to our final answer of 5 choose 2 times 1 6 squared times 5 6 cubed, or about 0.1608. And we can also use this general formula here through the same logic. Thank you.